Hi everybody, my name is Celso Jr. I'm a Microsoft Certified Solution Developer, Software Engineer student, Startups lover, and a casual investor of small cap stock as well. I've been working with design and development since 2001. It has been almost 16 years since that I made my first editing from Hello World. Nowadays, I work as programmer for an enterprise based on Tijuca, Rio de Janeiro, where I had the happiness to bring the microservice architecture to. This is an overview for the presentation. In this presentation, we will talk about three things: microservices, NANS, and VS Code. However, this is not a zero-to-hero tutorial where you could learn all about implementing microservices in 100% of the complexity involved in this. We will just see a simple implementation just to give you inspiration so that you can build your own microservices. So, microservices. Microservices is something that has become very popular nowadays, and many companies have adopted this architecture mainly to help solve some bottlenecks, scaling their applications. But a lot of people still don't have a clear idea of what a microservice is. If you search for microservice definition, for example, the wiki will tell you that microservice is a specialization of SOA, but I have to agree with Martin Fowler when he says that, quote, we cannot say there is a formal definition of the microservice architectural style, end quote. Several things help to identify what a microservice is, but I would say in a summarized and informal way that a microservice is an application module in the form of a small service or microservice with automated infrastructure that does one thing and does very well. We don't update microservice. We replace it. Sorry about the cartoons in this presentation, but I love cartoons and I believe you can get a better idea of what I'm saying with it. Microservices should be designed and built independently, so I can code it, I can test it, I can move it to staging and then swap to production as many times as I want because I can deploy it independently as well. The microservice should remain small, capable of being maintained by a small team. Do not create a collection of big monolithic services. Microservices should not be complex things. Do not implement unnecessary things. Do not implement things you think you will need just because other companies need it. Moreover, if you have a small team, do not build too many microservices as this can be difficult to orchestrate. when things grow and become a bit more complex, especially if those microservices were written in different language. When I think of architecture, I think it's made up of five things: methodology, process pattern, platform, and device. Waterfall was a long-used methodology. It worked very well for small applications, but the use of this methodology in large projects turned out to be very stressful. In the second phase of architecture evolution, we find a better way to develop software, now more focused on team and faster delivery. In this third phase, we have a very sophisticated infrastructure and we can take advantage of the cloud as a platform. Now we can change almost everything and we can do it quickly with continuous delivery, and some teams are adopting lean engineering with the cloud. The first time I heard about Nancy was through a blog post from Scott Hanselman, but on that occasion I didn't want to look around for more. I've only been more interested in Nancy because I wrote a very good talk about microservices from Richard Banks, Microsoft MVP from Australia, at NDC Sydney from 2016. So I decided to look for more talks from this guy, and I ended up finding one about Nancy as well. Simplicity. That is the reason why I'm in love with Nancy. Nancy is a very simple framework used to build HTTP-based services in .NET Core and Mono. The secret of Nancy's simplicity lies in conventions, which make it a very sensitive framework. If you don't declare your module as public, for example, Nancy won't be able to find it. Similar to the ASP.NET Core, Nancy also includes a simple built-in version of control container for small projects called TinyIOC that support dependency injection via constructor by default. So let's build this hello world as usual, but like I said, we will not go into too much details about Nancy now. We could use the Visual Studio to create a Nancy project, but since that we are talking about simplicity, we will use the command line for this. All you need is to have the YAML generator for ASP.NET Core project installed. So let's get started. Open the Windows PowerShell and go into desktop here. Let's create a ASP.NET project. The type of the project in our case is Nancy, and the name of the project will be Nancy Hello World, and hit enter. Wait a moment and Human will let you know that your project has been created. I confess I was asleep last night the first time I saw this $1. Maybe they could improve this someday. Anyway, now let's follow these steps here. Now going to the project folder and do .NET install. After that, we are able to run our Hello World project by typing .NET run. So as you can see here, we are listening at localhost at port 5000. So let's open Microsoft Edge and type this here. Here is our famous Hello World, and as you can see here down below is the generated HTML. Okay, let's go back to the slides. VS Code is a lightweight cross-platform code editor. In order to install the VS Code, you can visit its official website, which you can see in the description down below. Let's open the VS Code now. And just hit Ctrl C and code. There is not much to do here. We're not talking much about the bug settings, but basically here is the file launch.json. In this file is where you can create the possible debug settings that you can access here in this combo box here. And another thing you can do to improve the experience of using VS Code is to install some extension from the market. These are some of the extensions I like to use. I don't want to go into details about each extension now, but you can pause the presentation at that point and search for the names of those extensions from this text box here if you want. And Visual Studio Code also comes with this built-in terminal here, so you don't have to change screens to run command lines. And so now let's take a look at the liquidation project. As I said at the beginning, this is not a complete application because I did not have time to implement everything. This is just a starting point to inspire you to implement your own microservices. This project is inspired by a file uploaded by Philip Wagner. This project will be available in my GitHub account to anyone who wants to fork or download it. So please feel free to send pull requests with things I didn't have time to implement, as for example Docker support or connection to some database, test project, etc. Or even with bug fixes that I may have committed without realizing. This application doesn't do anything very interesting. It simply receives a CSV file generated by MS Excel that needs to be in UTF-8 due to Latin characters, and returns a formatted and validated TXT file following the business rules of another application. In a microservice perspective, it's a simple HTTP API which runs anywhere. It's a stateless microservice, but you can turn it into stateful if you want. It has a simple in-memory event store implemented. It uses log4net for logging. What else? It can receive an user ID from an API gateway to process requests. And it was written with functional programming in style in mind, but it is not 100% in functional style. In a Nancy perspective, you can see examples of content negotiation, bootstrapper, app settings, Nancy model binding, what else? Fluent validation, tiny IOC container, and so on. With C#6, we have some examples of tuples, inline try-parse, expression butters, auto property initializers, etc. Let me see. Okay, let's take a look at the app settings file. I created a configuration file that I made by bind and registered in the container. This way I can inject the configuration via the constructor in any class, so I can access the configurations easily. All you have to do is create a configuration file of the type .json, .xml, or .ini, like the one here that I'm showing now. And then you need to create an interface. And then a class that implements this interface so that we can do the control inversion later. In the startup.cs here. We pasted the name of our JSON file here. We create a bind here. And pasted it to our custom bootstrapper here. Then we can register this in the inversion control container of Nancy, that is tiny IOC. A good programming practice is to create a log system for your application, and here, as you can see, we are using log4net, but I decided not to register log4net in the container, but I left it commented. If someone thinks differently, to configure a log4net, I have to create a separate configuration file that is down here. You can study log4net for settings that suit your needs, but basically I was defining here that debug and info levels will only print to the console, and the warm and error levels will only print to the file, and that will be saved at this custom address here. I've also edited the assembly as liquidations assembly info.cs here. And here, this is where we initialize our logger for this module or class. And here, finally, is where we make a debug log that will appear on the console only. So this is basically the workflow with the log4net. It is important to remember to include such configuration files here in the .cs project, so that they are delivered along with the published project. If you forget, your compiler can complain about it. What else? Let me see. Something else would like to talk about is also about API. We have this service here in the infra folder that makes a request to API. Among other things, with API you can create fake APIs with custom terms to test your applications. If you would like to know API, just access the link below in the description of this video. Okay. To conclude, we will make a simple publish of this application so that we can better understand its operation. For this, let's open the Google terminal from the menu view, integrated terminal, and type .NET publish. So apparently nothing will happen, but actually a folder was created here inside the bin by accessing that folder. We can see that our configuration files are there. They are those two here. Now what we need to do to run our project is to open PowerShell and just type .NET, this time without run, just placing the generated DLL as parameter in that way. So hit enter, and now we'll use Postman to make the request. So this is the settings I'm using to send the file. Let's grab a text file here. Okay, and click the send button. Okay, as you can see, the file has been processed and 200 OK status message has been returned. Now we will copy the download the link here in our terminal by hitting enter to download the processed file. Let's go to Microsoft Edge, paste it here and hit enter. Now we can save our .txt file here. Okay, so I won't open this processed file because my test file still has some real and private information. And back here to Postman, we can see that an event was raised for this request that another microservice could be looking at. Okay, so that's it. Thank you for your time and see you next time. Bye bye.